In this video, we are going to learn how to add and subtract rational expressions. The process is very similar to adding and subtracting numerical fractions. And if you recall from elementary school, we used to look at the denominators, and if the denominators were not the same, we used to find the LCD, also known as the least common denominator. The only difference is that the denominators now are polynomials, not just numbers. So let's go ahead and try to find the LCD between these two polynomials. The least common denominator between x and x squared is x to the second power. So we are going to rewrite the first fraction in a way that the common denominator, the LCD, is emphasized. So to achieve that, we are going to multiply both the numerator and the denominator by x, because x times x gives us x squared, which is the LCD. So we get 2x over x to the second power. We do not need to modify the second fraction because the denominator of the second expression is already the LCD. So we are just going to copy that. So we have 3 over x squared. And now that we have a common denominator, we are simply going to keep that denominator. Don't ever add or subtract the denominators. Just keep the common denominator. And we are going to operate the numerator. So we have 2x minus 3, which is a binomial. Then we are going to look again to see if there is anything that we can simplify. But in this case, we cannot. Of course, we should remove those values for which the expression is undefined from the very beginning. So let's make sure that x is not equal to 0. We do not want the denominator to become 0. All right, let's look at another example. In the second example, we are going to also find the least common denominator because the denominators are not the same. But to do that, first we need to factor each denominator. So we can write x squared minus 9 as x squared minus 3 to the second power. And then we can apply the difference of squares formula. So I can write that as x plus 3 times x minus 3. For the second fraction, we keep the numerator. And we recognize that this trinomial can be written as the square of x minus 3. This is a perfect square trinomial. So that's the formula that I applied here. And now if we look at the two denominators and we compare them, we notice that each of them has x minus 3 as a common factor. But the least common denominator, let's write it here on the side, the LCD, will be the product between the common factors and those factors that are not common. So I'm going to take x plus 3. And then for the common factor, which is x minus 3, I'm going to take that to the highest power. So I'm going to take it to the second power. So this is the LCD. Now let's go ahead and convert each fraction so that the new denominator is the LCD. So to do that, we're going to multiply the numerator and the denominator by what is missing to get to this LCD. So this first fraction, we need to multiply it by x minus 3. Up and down, right? We're going to amplify this fraction by x minus 3. And then the second fraction, we need to multiply it by x plus 3 to get to our least common denominator. Now that we have the same denominator, which is equal to the LCD, we can go ahead and copy the common denominator. So our new denominator will be x plus 3 times x minus 3 squared. And for the numerator, we are going to add these two numerators together. So x times x minus 3 plus 2 times x plus 3. Now, we need to apply the distributive property and then combine the like terms. So we're going to distribute x to open up the first parenthesis, and then we're going to multiply 2 with each of those terms to open up the second parenthesis. And then we're going to combine the like terms. So what do we have? We have x squared minus 3x plus 2x plus 6 over x plus 3 times x minus 3 squared. Let's go ahead and combine the like terms. We only have one pair of like terms right here in the middle. Negative 3x plus 2x is negative x. So this expression becomes x squared minus x plus 6 over x plus 3 times x minus 3 squared. Let's do one more example. In this last example, we are going to start again by factoring the denominators and finding the LCD. So let's rewrite each of the denominators in a factored form. I could write x squared minus x minus 6 as the product between x minus 3 and x plus 2. Because negative 3 times 2 is negative 6, and negative 3 plus 2 is negative 1, which is this middle coefficient here. All right, and then we are going to rewrite x squared minus 4 as a difference of squares. So I'm going to write x squared minus 2 to the second power. And we're going to apply the difference of squares formula. So this becomes x plus 2 times x minus 2. Now, the LCD will be the product between x minus 3, x plus 2, which is a common term between these two denominators, and x minus 2. So we have to convert each fraction to a fraction that would have that LCD as the new denominator. So let's go ahead and multiply the first fraction by what is missing to take us to the LCD. So what is missing here is x minus 2. So we're going to multiply both the numerator and the denominator by x minus 2. The second fraction, we're going to multiply the numerator and the denominator by x minus 3. Now we can see that both fractions have the same denominator, which is the same as the LCD. So we're going to go ahead and copy that LCD as our denominator, which is x minus 3 times x plus 2 times x minus 2. And for the numerators, we are going to apply the distributive property, right? We're going to multiply 2x with x, so that gives us 2x squared. And then 2x times negative 2 is negative 4x. And then we're going to distribute this negative 3. So we have negative 3x. Negative times negative gives us a positive 9. And then all we have to do now is to combine the like terms, which are negative 4x and negative 3x. So we have 2x squared minus 7x plus 9 over x minus 3 times x plus 2 times x minus 2. So again, adding or subtracting rational expressions, is very similar to adding and subtracting regular fractions.